The science behind nature's most powerful storm, hurricanes. Nature's most powerful and destructive storms, but have you ever wondered how these mighty forces of nature actually form? Before a hurricane begins its life as a violent storm, it starts as something quite peaceful, a calm, warm ocean. But under the right conditions, this tranquility can quickly transform into chaos. Hurricanes are born over warm tropical water. Think temperatures of at least 80 degrees Fahrenheit, that's 27 degrees Celsius or higher. This warm water acts as fuel, providing the energy needed for the storm to develop. As the sun heats the ocean, water evaporates and rises into the atmosphere, carrying with it tons of moisture. This is where things start to get interesting. For a hurricane to form, we also need a little help from winds. As warm, moist air rises, it creates an area of low pressure at the surface. This causes surrounding air to rush in, and when winds converge and spiral, they begin to rotate. This is the birth of a tropical disturbance. If the conditions are right, these clusters of thunderstorms start to organize and rotate thanks to the Coriolis effect caused by the Earth's rotation. The Coriolis effect caused the storm system to spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Without this, a hurricane wouldn't develop its signature spiral shape. As a storm strengthens, more and more warm, moist air is drawn into the system. This rising air cools and condenses into clouds, releasing latent heat which powers the storm even further. If the storm continues to gather strength, it can evolve from a tropical depression into a tropical storm. But what makes it a hurricane? Winds reaching a sustained speed of 74 miles per hour, that's 199 kilometers per hour or more. From here, hurricanes are classified into categories from 1 to 5 based on wind speeds. The higher the category, the more destructive the storm. One of the most fascinating features of a hurricane is its eye. At the center of the storm, the eye is deceptively calm. While winds rage around the eyeball, the most dangerous part of the hurricane, the eye itself, can be eerily quiet. Surrounding the eye is the eyeball, where the strongest winds and heaviest rainfalls occur. Outside of that are the rain bands spiraling outward and bringing intense rain and thunderstorms. When a hurricane makes landfall, the real danger begins: high winds, flooding from torrential rain, and deadly storm surges. But as the storm moves inland, it begins to weaken. Without the warm ocean to fuel it, the hurricane starts to lose strength. Though the storm may weaken, it can still cause devastating damage through flooding and high winds. That's why it's critical to take every hurricane seriously, even after it's downgraded. Hurricanes, also known as typhoons or cyclones in other parts of the world, are a global phenomenon. These storms have different names depending on where they form, but the process remains the same. No matter where they occur, these storms are a reminder to the immense power of nature and how we must prepare for the worst when they approach. So next time you hear about a hurricane forming, remember the delicate balance of conditions that turns a calm, sunny ocean into one of the nature's most formidable forces. So today we're going to discuss about the Hurricane Helene that came into existence in September 2024. In the vast history of hurricanes, few storms have left their mark like Hurricane Helene. Powerful and destructive force, Helene unleashed chaos on everything in its path. Today, we take a look at the storm's journey, its devastation, and the lessons we have learned from one of the nature's most fearsome tempests. So it all began in early September when a tropical wave moved off from the south coast of Africa. It all began in early September when a tropical wave moved off the coast of Africa. As it drifted over the warm waters of the Atlantic, the conditions were perfect for something much more dangerous to develop. Within days, this disturbance became organized, growing into a tropical depression. By September 8th, it strengthened further into Tropical Storm Helene, quickly gathering power from the ocean's warm waters. But this was just the beginning. On September 9th, Helene reached hurricane status, its winds howling at over 75 miles per hour. The storm would continue to intensify, reaching its peak as a Category 3 hurricane with sustained winds of 120 miles per hour, that's 200 kilometers per hour. As Hurricane Helene tracked across the Atlantic, it posed a significant threat to the Cape Verde Islands and parts of West Africa. Though it stayed mostly offshore, the storm's most powerful winds and dangerous swells impacted coastal regions, causing flooding and widespread disruption. The storm's outer rain bands brought heavy rain and large waves, leading to coastal flooding and infrastructure damage. Coastal communities braced for impact as Helene's wind uprooted trees, knocked out power, and damaged homes. Though Helene stayed mainly at sea, it left behind a legacy of destruction. Torrential rains caused widespread flooding, not just along the coast but also inland, where overflowing rivers devastated communities. While Helene's land impacts were serious, the storm's far-reaching effects extended beyond Africa. As it moved northward across the Atlantic, it stirred up dangerous surf and rip currents, even affecting the coasts of Europe. By the time Helene reached the shores of the British Isles, it had weakened to a tropical storm. But its heavy rains and strong winds still battered parts of Ireland and the United Kingdom. Residents were warned of potential flooding, and transportation was severely impacted as gusty winds knocked down power lines and caused travel disruptions. Hurricane Helene, though not the most destructive storm in history, taught us valuable lessons about the unpredictable nature of hurricanes. Its rapid intensification reminded us how quickly these systems can evolve. Experts pointed to the warming oceans as a key factor in Helene's strength. With sea surface temperatures rising, hurricanes have the potential to become more intense and more frequent in the future. Helene is a clear example of how storms can rapidly intensify and how we must be prepared even when they don't make direct landfall. The indirect impacts, such as heavy rains, storm surges, and coastal flooding, can be just as devastating. In the aftermath of Hurricane Helene, communities began the long processes of recovery. Though the damage was significant, the resilience of those affected showed through. Relief efforts from governments and aid organizations helped provide much-needed support to those hit hardest. It's a reminder that while we cannot prevent these storms, we can prepare for them and we can help each other recover. Hurricane Helene may have passed, but its legacy remains. Hurricane Helene may have passed, but its legacy remains. It serves as a stark reminder of the power of nature and the importance of preparedness in the face of such destructive forces. As we look to the future, we must continue to respect the power of these storms, learn from each one, and take steps to protect our communities and our planet from the increasing threats they pose. Thank you so much for watching. If you found this video informative, be sure to like, subscribe, and hit the bell for more stories and the incredible forces that shape our world.